Thank you, madam, for the nice introduction about me and regarding the topic. Respected madam, Dr. Geetha, head of the Department of Physiology, Kollam Medical College, Dr. Jesse, and other members of the Kerala Physiology Association, my dear friends and colleagues. Today's topic is, as Madam said, gut microbiota. I don't know, when Dr. Anish and Dr. Gishma asked me whether I could do a lecture on this topic, first question was why they did ask me, but because I'm not a physiologist, I'm a purely clinician. Clinician doing gastroenterology work. At present, gut microbiota is in the realm of research people. I don't have any experience of research in this area. That is my disclosure. But I do have some interest in microbiota. Last few years, I used to read a little bit about microbiota. That is the only interest. Because of that, recently, I wrote an article in Malayalam, in one of the Malayalam dailies. Probably that is the reason why Dr. Gishma asked me to do a lecture. Second point is, this is something about microbiology, not about physiology. Am I right? But no. Physiology is everything in medicine. I believe so. Science of physiology is concerned with the normal functions of the body. When we clinicians percuss, auscultate, count the blood counts, analyze the excreta, elicit the reflexes, speak about valves, pressures, and calories, we practice physiology, not medicine. Whatever I know in physiology is because of this person and my teachers at Trivandrum Medical College. I tried to read this book written by Arthur C. Guyton. He was a pure physiologist. He developed polio when he was a junior faculty and paralyzed both limbs. In spite of that, he continued his passion in physiology, published more than 600 articles in peer-reviewed journals. He has got 8 children. One of his sons told at a function, this man gave us the mind, but we gave him the legs to walk. I pay my respect to this person. I remember this person and try to say something in physiology. I'm going to evolution of human. This is the evolution of Earth in a calendar month. We almost 3 weeks, more than 3 weeks, it was ruled by microbes only. It was a world of microbes. Only the last 4 days, animals and plants occupied this planet. On these 4 days, we occupied only the last 30 minutes of the last day. Only 0.3 million years ago, we came into this planet. So, we live in a microbial world. That's the first statement I want to say. We live in a microbial world, and our genome signature is mainly microbial. You can see 37% bacterial and 28% eukaryotic than human. You can ask a question here, who are we? Little bit of philosophy, but I am not going into it. And this is a image which I have taken from the Google. There is a, you need to know, there is a museum in Amsterdam on microbes only. It's only microbes. You can talk to the microbes, you can play with the microbes. There is something to attract the crowd. There is a kissometer. If you kiss on that, you will transfer 80 million microbes with every kiss you make with another person. See how much of people living inside me, inside us. With a kiss, if you can transfer 80 million microbes, we are microbes only. This story started almost 300 years ago. Again in Netherlands, Amsterdam, near Amsterdam, a city named Delft. You all may be knowing him, Anthony van Leeuwenhoek. He was not a doctor, he was not a scientist. He was a worker working in a linen store. But he had a passion to look everything under the microscope, and this microscope was made by him, which has got a magnification of almost 150 to 300 times above the normal. This man was ahead of his time. He looked through the microscope everything which he saw. Incidentally, he looked at his dental plaques, he looked at his feces, and he astonished. I almost saw with great wonder, in the set matter, there were many very little animalcules. He didn't know that it is microbes. He termed as animalcules. Very prettily moving. They are moving. They are living things. This is where we start our journey. But I told you, he was almost 200 years ahead of his time. Next 200 years, nothing happened. Nobody could reproduce what he has said, because he was making a microscope, the technology which is not available to any one of them. And he was very, very cunning that he didn't tell to anybody also. After 200 years, these gentlemen came into the picture. All of you must be knowing Louis Pasteur and Robert Koch. But this is after 200 years. That period was a vacuum. Nothing happened during that period. And what they did was, they established the germ theory of disease. There the day started. They have become the villain. Microbes have become the villain. We tried to eliminate, eradicate these little creatures from everywhere. That was our mission. That became the mission of the science, medical science. But again, during this period, during the period of Robert Cox and Louis Pasteur, there's another gentleman by name Stamen Grigoro. He was a military doctor. When he goes for his duty, he was a Bulgarian. His wife used to give him very thick milk, yogurt. Yoga means thick and at means milk. She used to give him thick milk, which is very famous in Bulgaria. Almost 4,000 years they were using this so-called thick milk yogurt. But this gentleman wanted to find out why this is so important. He tried to look at it under microscope and found the bacilli, Lactobacillus bulgaricus, which gets commercialized after that. Since that time, there are plenty of these yogurt preparations all over the world. He found out that the nutritional property of this milk is due to Lactobacillus bulgarius. See, I'm telling you a little bit of history, but I'm very much interested in history, so just bear with me. Because you need to know how we reached here. Then only we will be able to go forward. Here comes another gentleman, a crazy fellow, who committed suicide twice. He is the man who, Elie McGigoff, you maybe know him as a person, as a father of immunology. He is the person who found out what is phagocytosis and macrophages are. But I want to consider him as a father of probiotics. After his 2 episodes of suicide, he wanted to live longer. Only at that time, the other gentleman found out yogurt with lactobacillus. And he made a theory that colon is the seat of all problems which humans are facing. And people at that time were resecting colon, part of it. The colon length was too much, so we are getting diseases. So part of the colon was being, people tried to resect it to live longer. But this guy found that if we can manipulate the problem in the gut, what is the problem? There are plenty of microbes. So you just manipulate the microbe. So he manipulated with the microbe with the use of yogurt. And he lived for some more years. So he is supposed to be the father of probiotics. This is another story. World War I, 1917. In the Balkan area, people were dying due to Shigella, dysentery. But he noticed that one of the German person is not developing any of these infections. He is remaining very healthy, even in the midst of shigellosis all around. He wanted to know why this person is not developing Shigella. He tried to look at his stool, and he found that there is one bacteria named E. coli. We all know that E. coli is a villain. We count coli count in the feces, in the water, to know whether the water can be drunk or not. But there is another strain of E. coli, Nissel. It is after his name, Alfred Nissel. He found out that bacilli, and that is why that guy didn't develop Shigella, is because of the then proved theory of colonization resistance. The antagonist. He named it as antagonist. He didn't term it as colonization resistance. He named it as antagonist, which antagonize the growth of Shigella. But the commercial people were very cunning. They made a preparation out of this bacteria, And it is there in the market since 100 years. In different names, different countries. This simple observation, this you can say it as a serendipity, made the thing. Another guy named Henry Ballot, he was I think it's a French. Cholera was happening at that time in France in 1920s. But he noticed that some of the people didn't develop cholera, even in the midst of the crowd. And those people were drinking a skin peel from a juice containing the skin peel of mangosteen and lychee. Those who are drinking this juice are not developing cholera. What he did was, he did some experiments and found out that there is a fungus named Saccharomyces boulardii in this preparation that prevents the development of cholera. And almost all of them will be familiar with this preparation econome. Our pediatricians, gastroenterologists, physicians, everybody used to write children with cholera, children with diarrhea and adults with diarrhea. This is an invention which happened through this. Coming from the microbes, I'm coming to the gut, because it is gut microbiota, which is my topic. I'm coming to two physiologists of 19th century who laid the foundation of gut physiology. You all will be knowing, I don't have to tell you about Ernest Starling and William Bayliss. He is a person of laws of heart, laws of intestine, and laws of so many things. What he found was, if you separate the gut from all the nervous connections from above, and if you increase the pressure in the gut will move with the oral contraction, proximal contraction, and an anal relaxation. See, we move our hand, we move our leg, we move our body, but our brain has to think whether you move or not. He will say whether you need to move or not. Here, all the connections has been separated, still the intestine moves. It has got an intrinsic nervous system. I'll come to it a little bit later. This gentleman, his name is Trendelenburg, Ulrich George Trendelenburg. What he did was, he not only separated the bowel, he separated the bowel segment from the body and put it in an organ bath in a J-shaped tube. And then he increased the pressure. He blew through that segment of the bowel, and he saw the same oral contraction and anal relaxation. So now it is clear, gut is God. Gut is brain. Okay, we found that there is a brain inside. So we have a brain inside our gut. That is what these three gentlemen did to physiology. We are moving, personally, we gastroenterologists move on this theory, and we have found out so many things after that. So gut is a remarkable organ. We know that it helps in your digestion and absorption. It is not alone. It's the largest immune organ in our body. Actually, gut is the place through which our immune system develops. I will come to it. It's the largest endocrine organ in the body. The first hormone in the body was secretin. This was again invented by Bailey and so the gut produces more than 20 hormones till now. So it is the largest endocrine organ. It is the mega store of serotonin. We know when we get depressed, when we are stressed, it's the serotonin which is lacking. It's the mega store of serotonin. 95% of the serotonin in the body is produced in the gut, not in the brain, not in the peripheral nervous system. We have got an intrinsic nervous system, I have told you, and we taste, we smell with the taste receptors, smell receptors in the mouth and nose. But do you think that that is the largest smell taste receptors? No. We have the largest number of receptors in the body are there in the gut. I think I'm telling too much about gut. So I'm not going into this gut sensation, gut reactions, but because I think there was a talk yesterday on brain-gut axis. All this comes under that. I'm not touching that. Just a little thing about our thoughtful gut. See, popular consensus is that intestine is a repulsive piece of anatomy. Shape is nauseating, disgusting, contents, and bad smell. It is primitive, it is slimy, it is snake-like moving. It lies in the abdomen like something coiled within the belly. But you know, this remnant of, there is an intrinsic nervous system is there, I told you. This is the remnant of our revolutionary past. Again, just to take you through the journey of the evolution, just to think of the Hydra which we have studied in our school days. Hydra takes nutrients from the water, expels through the other end. But again, it doesn't have a brain, it doesn't think, but it has a nervous system to move these contents from the oral part to the anal part. So, which is the first brain, which is the second brain? You can decide. There are 20 million nerve cells in the small intestine alone. But when you consider the whole of the GI tract, it will be the double of this. It will be more than the number of neurons in the peripheral nervous system. There are more neurotransmitters than in the brain produced by the enteric nervous system. Descartes, when he said, I think, therefore I am, I'm just modifying it. He can think because the gut lets him to think. If the guts do a strike, he may not be able to think. He will omit, he will be in the loo. There will not be any time for him to think. I'm coming from the gut to the microbiota. See, this is a beautiful picture. This is the epithelium, which separates our body, our interior from the exterior. There's the lumen. On the lumen, there is a layer of mucus. This is the layer of mucus which separates our epithelial layer from the lumen. In the lumen, there are colorful things are there. Seems like a pookalam at the time of Onam. These are the microbes inside your lumen. It's a scanning electron microscopy picture of a real picture. It's not something which is a cartoon. So, our microbes lie between the epithelium and the lumen. It has got many functions to do. See, this is the mucus layer. These are the microbes. This mucous layer separates the mucous, the epithelium from the interior. There's an immunological barrier. Again, there's a chemical barrier, there's a physical barrier, there's an immunological barrier to prevent this bacteria to come into contact with the epithelium. So we have a strong barrier which prevents. But when this barrier gets broken down, all these problems will occur. I told you in the beginning that the microbes were considered were the killer germs, killer microbes, and we have reached to a stage where to live with the bacteria, and we have considered them as our fellow travelers. This is the story of the media. We have progressed over the years to reach the stage of fellow travelers. What do? They do everything. They make vitamins. They defend against the harmful microorganisms. They teach the immune system to tell friends from foes. They influence the calories you have taken. They will tell you whether you need to become lean or obese. They produce important molecules that travel around the body, named as neurotransmitters, cytokines, metabolic products, so many of them. They produce serotonin. I told you the importance. See, when did we start thinking about the microbial world as our fellow travelers or friends? See, this is an article published in New England Journal of Medicine in 2006, widely quoted. You can see this period, the last 100 years, has been an era of great change. We are exploring the outer reaches of the universe. We traveled across the continents in hours. At the same time, we started to warm the earth, depleting the oceans. And during this period, our infant mortality came down, our longevity increased to remarkable levels. You can see rheumatic fever are almost non-existent nowadays. Measles, mumps, we eradicated to a level. Hepatitis, of course, it is very rare. Tuberculosis is still there, but it has come down remarkably. All these changes happen. But at the same time, something is happening on the other side. Multiple sclerosis, diabetes, asthma, obesity, Crohn's disease, a number of chronic inflammatory conditions are going up. So the scientific revolutions at one end has increased our longevity. At the other end, we are becoming more obese. We are suffering from chronic inflammatory conditions which were non-existent before 50 years. So there is some problem with our development, there is some problem with our... So people try to look into, as like the macro environment, people started to look into the micro environment. This is, again, the same story of... See, when I was doing my DM gastroenterology at Trivandrum Medical College, when we diagnosed as Crohn's disease, our teachers used to say, "Are you sure? Are you sure it is not tuberculosis?" That is the immediate DD, differential diagnosis. It is very, very rare even at that time. That is only 20 years back. But now, it is more common than tuberculosis in our part of the country. It is very common. Tuberculosis of the intestine we very rarely used to see, but I used to diagnose as Crohn's and ulcerative colitis, at least one new case every week. That is the quantum. So what has happened? When we look at this, we can see that, this is the number of cells in our body. We have more microbes than the number of cells in our body. It can be 1:10, or you can just make a connection. The numbers are constantly changing because we are still learning. But what I want you to do is look at this. We have got 23,000 genes in our body. That is what we have proved with our human genome project. And with this 23,000 genes are less than the number of genes in a fruit fly. That's the problem. We have less genes than in a fruit fly, Drosophila. So, to carry out our functions, there should be something more. But we have, recent number says, we have 9 million genes contained in our microbes, which we carry. They are not sitting idle. They must be doing something for us. Very, very clear. So, we have 10 raised to 14 cells and 23,000 genes. That's what I told you. But we become complete human only with these numbers only. We are incomplete. We are 1%. 99% is being occupied by our microbes. When you take the genomic history. This is a head cover of the Economist magazine, which came few years back. Microbes make the man. That's the truth. Where it all began? That is a story which you have to take. Our evolutionary history, again, we have to go back. The problem is the human genomes, we all know, human genome evolves very slowly. To make a change, to make a mutation in the human genome, it takes generations. But our microbial genome adapts very, very rapidly. The multiplication is 20 minutes to 1 day. So they will adapt genes, they will transfer genes, they will produce more genes according to our needs. That's what happens. So when our dietary practices changes from the hunter-gatherer to burgers and pastries, this change happened. This is the same. We have evolved from hunter-gatherer to an agriculture society, to the industrial world. We produced processed, sanitized, hyper-processed milk, which led on to extinction of the microbes which we were carrying over generations. With many generations, our microbial diversity, I will come to this term. This will be a term which I will be using very frequently. This microbial diversity comes down with years we pass by. But there was some change happening. With every generation, we were acquiring the lost microbes to an extent through our food and the environment. Again, that is being lost since the last 50 years. These are the culprits. If our diet has changed, our sanitation has changed, we are using antibiotics every now and then. We are born by a different method most of the time. So here, I just want to show you one thing. Just see, this is the number of species of genera of bacteria which has got extinct over the years and were being replaced by a group of bacteria or microbes which may not be healthy for us. How this change happened? This change happened because of the genomic sequencing which happened over the last 20, 30 years. Genomic sequencing was one thing which was very costly. 5 years back, I'm not going far away, 5 years back, to sequence your fecal microbiota, it should have taken $1 to $2 million. Now, it takes only $100. So it has become so popular, it has become less costly, so we started finding out what are living within us. There are several methods, microscopy. No, I'm sorry. There are several methods, microscopy, culture, metagenomics, metatranscriptomics, metaproteomics, metabolomics. These are all things which are happening around us. With these technologies, we were able to find out what are living within us. I'm not going into details. This is each one is a topic by itself. I will be telling you the diversity. You all know what is biodiversity is. Biodiversity is there are a lot of many species, many genera living together. This is biodiverse. This is a type of biodiverse. Our country is biodiverse, and our gut also is. Biodiverse. But the thing is, in the midst of biodiversity, we need to find out which is healthy and which is unhealthy, which is normal and which is abnormal. These are terms which are very, very relative, but I am using it. Why this biodiversity means it contains virus, bacteria, protists, algae, fungi. There are so many microbial agents in our gut. We know very little. Whatever we know is mainly about the bacteria. There is much to be learned. In the human microbiome, we know that there are more than 50 phyla, more than 2,000 genera, more than 10,000 species. The numbers, I am correcting it because it's keep changing. So this is the amount of, is the diversity of microbiome we are harboring. Other than the gut microbiome, we have microbes in the respiratory tract, oral cavity, skin, vagina. This is a unique. I will be telling you, when there is a diverse number of organisms, it is more healthy. That is the usual, but that doesn't apply here. Vagina. Mainly it is being occupied by the lactobacilli. So diversity is not always good. When this is being occupied by multiple other organisms, it becomes less diverse, it becomes less healthy. I'm just trying to tell you what diversity means. Diversity, it varies between individuals, it varies between sites, it varies from the infancy to adulthood. Your organism keeps changing. It is dynamic. And the number of organisms in our gut varies from the oral cavity to the colon. And the maximum number is seen in the colon, 10 raised to the power of 14 per ml, I think. And the majority of these organisms comes into two phyla, firmicutes and bacteroids. This is the two phyla which is seen in our colon, and the rest are only 5%. What are the factors which shape our microbiome, or what are the factors shaping the microbial diversity? That will start from the mother. I will come to it. See, with every generation, I have told you before, with every generation, our microbes, conserved group of microbes becomes less and less. But we transfer a certain group of microbes with every generation to the next generation. So there is a vertical transfer and there is a horizontal transfer. This is from where we get these microbes. Delivery mode is one thing which determines our microbial load, then the feeding method, then the environmental exposures. During this phase, it is low diverse, it is unstable, it's chaotic, but by the age of 3, it becomes more diverse and stable and continuous. We have vaginal delivery and C-section deliveries. I am not a critic of C-section deliveries. Some situations it is needed, it should be done, it's an advancement of the science. But what happens in a vaginal delivery is, when we deliver the baby through the vagina, we get the microbes which are destined to get to the baby from the vaginal tract, which is the lactobacillus, and some amount from the from the gut, and some from the skin mucosa. But when we deliver the baby by cesarean delivery, what happens is we are not getting the vaginal flora. We are not getting the fecal flora. What we are getting is only the skin flora and flora in the theater. So there is a marked change at the start of our journey. This is one thing which we need to be concerned. This is a study which undertook by the Maria Gloria. She's a microbiologist. She is very passionate about the vaginal microbiome. What she did was, she tried to study the bacterial flora in the newborn delivered by the vaginal route and the cesarean route, and try to look into what is the flora like. You can see the vaginal flora, seems to be much diverse, seems to be healthy. This is the C-section flora, baby flora. This is less diverse, seems to be organisms which are not being meant to be there. It's mostly skin flora. What she did was, that was an intervention trial. She, immediately after the delivery, she swabbed mother's vagina, and that swab she applied to the baby skin and the oral mucosa. And what she found was, she was able to increase the flora, she was able to change the flora composition. This is something which is happening. These are all this is a human study, but we can't take any conclusion out of this. These things are happening. That is what I'm telling you. Don't ask your obstetrician to do the same in the next month. No, these are things happening. Another thing which I want to tell you is about breast milk. There is something we all know that's a very, very nutritive thing. It contains so many things. Along with that, we need to understand that it is not sterile. It contains such a group of organisms which the mother wanted to transfer to the baby, which the nature has decided to transfer these organisms to the baby. It doesn't end there. Scientists all over the world were studying microbiota, breast milk, they found that there is something called oligosaccharides. These oligosaccharides are almost one-third of the weight of the breast milk. It's the third major component in the breast milk. One thing which you need to know is this oligosaccharides will not be digested in your gut. It's not getting absorbed in your gut. It reaches the colon undigested. So why is it there? Without mother's milk should contain something which cannot be absorbed, which cannot be digested. Later, people found that this is being utilized by the bacteria in the bowel, in the colon, and converts it into short-chain fatty acids and something. So it's a prebiotic. I will come to it. It's a prebiotic which the nature has given. So again, this has got a role. This oligosaccharides has a role in the immunity. It has got a role in the nervous system development, and so many other. It preferentially supports a group of bacteria in the colon named bifidobacteria. So this is again something the nature has given. So when you give formula milk, you are lacking this. Our biotechnology could not make something similar to oligosaccharides till now. So this is, over the years, till 3 years, our bacteria flora increases, it becomes more diverse, and it reaches to a level where it becomes less chaotic and becomes more stable. Along with this development, our immune system or our microbiota teaches our immune system to develop, and this also comes to a stable state by the age of 3 to 4. So our immune system develops in parallel with the microbiota. This is one thing which you can see. This is markedly diverse when you till the 3 years of age. After that, it becomes more stable. So till 3 years, the development of the child is a critical period during which we need to nurture this microbiota in the gut, for which we have to do things which will be helpful for that. The next important point in the diversity of the microbiota is the diet. The more diverse the diet, the more diverse the microbiota becomes. Diet determines the microbiota. Diet determines the physiology of the human being. Microbiota determines the physiology, that is through the diet. Every physiological process in your body occurs through the metabolic products, that is the metabolome, produced by the microbiota. Almost more than 1/3, it comes around more than 50,000 of the metabolic products in our body are from microbiota. That is what dictates how we evolve. I'd like to tell you what has happened over the years. We were having food from the kitchen, it changed to fast food burgers, frozen entries, processed snacks. We are now ordering the food with the touch of a button. It contains sweeteners, emulsifiers, coloring agents, flavorings, extra fat, added sugar, vital glutens, and extra calories. All this changes your microbiota. All this changes your microbiota. All this changes your physiology. people try to learn what's the difference between the industrial world microbiome and the traditional group. But we can't go back. But there are some traditional group living in several parts of the world. People try to learn from them. When you look at this, see, this is from the traditional group, several groups, microbiota, is entirely different from the industrial world. There are several studies looking into this group is entirely different. So you can assume that something has changed over the generations. There is a 50% reduction in the diversity of the microbiome when we move from the traditional communities to the industrialized world, that is US. So there is a change. The traditional groups were eating food rich in plants, occasional bits of meat. They have got a similar mix of microbes, but is entirely different study after study has proved that, entirely different from North Americans or the industrialist world. This is an article published in Science Journal. The cover page was Seasons of the Gut. What I want to convey is the microbial flora changes over seasons. This is a traditional community in Venezuela, Hadza people, tribal community. They have got 2 seasons. Actually, they've got a wet season, they've got a dry season. During the dry season, they are able to wander around, they are able to hunt lean meat animals, and at that period of time, their diet will contain meat along with tubers, which is their staple diet. But during the wet season, they usually don't take meat. It's only tubers, honey, and berries. This is their diet. People try to look into what happens during that wet and dry period. You can see the microbiome in the wet period and dry period are entirely different. So, during the wet period, the microbiome somewhat similar to the industrialized world. So, what you eat is the prime determinant of what your microbiome will be. Another evidence. What happened over these years is one important factor in the diet is fiber. In the traditional groups, we were consuming about 100 to 150 grams of fiber. Over the years, it has come down to 15 grams or less than that. We rarely consume fiber. What has happened? You can see, this is a fiber-consuming flora with reduction in the fiber amount. There is extinction of the several of the flora, which these are all human studies. I talked about the mode of delivery, talked about the food. Another important factor is the environment. With the change in the environment, we are living in flats. There are no greeneries around. So we are not getting any traditional microbes. Our children are playing with computers and mobiles rather than playing on the ground. These things also, this is a group of people living in an industrialized world. Ireland. There is a traditional community. Previously, they used to travel a lot. That's why called Irish travelers. But nowadays they are not traveling. But they live in a separate group where they have got a high sibling count, large extended families, close living quarters. They have got a proximity to animals. Their children predominantly play in the ground. They have got a microbiome flora which is equivalent to the traditional communities. Again, the environment plays a role. This is something, this is a study which have on 2 subjects. Fecal samples were collected throughout the year, every day. And you can see almost in the 2 subjects, the flora remained more or less stable with little bit of effect on these 2 points. What happened at these 2 points? Subject A traveled at that time. This orange group of microbe has come down during the period of travel. That was a healthy microbe that has come down during the period of travel, but it regained when he came back to the original place, but not to the original level. This is something which makes the travel, during travel, what happens during travel. In subject B, what happened was he developed a diarrheal infection at this point of time. You can see this blue or violet. That is, during that infection, that bacterial species has come down remarkably, and it didn't regain even after resolution of infection. You might have seen people complaining about what we call it as irritable bowel syndrome. They used to complain, they developed an infection, they developed a diarrhea. After that, it didn't become normal. This is what happens. It didn't come back to normal. Again, in the same patient, there is the orange group. It was there, but during the infection, that has gone up and remained high. Whether this is the one which compensated the violet flora. So these things happen in our gut. So I think I will skip this because again, one experiment on a baby. Okay, I will just. It's a healthy baby born. Till the age of 2.5 years, this Ruth Lay, this is a microbiologist at the Cornell University, analyzed 60 times during this 2.5 years. She analyzed the fecal matter. What she found out was, and this baby was breastfed exclusively for 4.5 months. After that, the breast milk was given along with the solid foods. And by 9 months she stopped breast milk. You can see the flora changes with every stage of the life. There was a fever. There is a change in the flora. You can see that red color coming up. There was a use of antibiotics, which changes the flora remarkably. So this is what happens. With every life events, your flora changes, but on a whole, it looks like stable if there is no drastic changes. This is what I was telling in the last few slides. It is a dynamic change. It happens over a time scale. It changes every day, every hour, every minute. What you eat, whom you interact with, whom you live with, and who you are going to shake hands with. All this matters. Coming to the previous image, this is the intestinal barrier which I was discussing. When this flora changes, when the diversity becomes less, when it becomes unstable, what happens is, I have told you, this is the mucus layer. This is the one which separates the epithelium from your lumen, which contains the microorganisms. When the flora changes, usually this mucus is produced by the enterocytes. Short chain fatty acids, which I discussed earlier, is the nutrient for this enterocytes. So when there are no favorable bacteria to produce short chain fatty acids. There is no nutrient for the colonocytes, so mucus is not produced. It's not produced, and in spite of that, what happens? These bacteria utilizes the mucus as the changed flora utilize this mucus as their nutrient. So the mucus thickness comes down drastically. This is what happens in an altered, less diverse flora. Mucus thickness comes down. So when the mucus thickness comes down, these bacteria can get into the epithelial layer and into the bloodstream. So this is the healthy mucosa. Short chain fatty acids are produced. This is being utilized by the enterocytes, and it produces a thick mucus layer. When there is a pathogenic bacteria, there is no significant mucus layer. Mucus is being utilized by the pathogenic bacteria, and the bacteria enter in the gut stream, gets through the barriers, all these barriers, and enters into the systemic circulation, producing a stage of endotoxemia and chronic inflammatory problems. This is in simple ways to say what happens in an altered flora. This is how this short chain fatty acids and bile acids act on the mucosa through these receptors on the enterocytes and the endocrine cells. So, microbial flora in the gut, if you want to remain in harmony with you, it's like an orchestra. Microbiota is the musicians, and microbiome, the genetic component, is the orchestra, the whole orchestra, and metagenome is the tunes. It depends on the microbiota whether the music is going to be good or not. So over the years, we evolved, we adapted, we are dependent on the microbiota. It's not a fight between the microbiota and you. It's a co-evolution, it's a co-adaptation, it's a co-dependent. It's not the survival of the fittest, it is symbiotic. It's a relation of symbiosis. This is a display. I will skip this slide. So this is microbiota produces these metabolic products. They act on the different organs to metabolome and produces healthy state of affair or the disease state. It can be inflammatory bowel disease, there can be liver disease, chronic liver disease. All this basically comes to the altered dysbiotic flora in the gut. I'm not going into the pathology part. I'm talking in a physiology conference. That is why I just restrict to the physiology of the microbiota. So what can we do? This is what happens. You all must be familiar with this pyramid of food, Mediterranean, so-called famous Mediterranean diet. The point here is every day you eat a plant-based diet. That is what Mediterranean diet pyramid tells you. But what I want to specify is this part. Be physically active. Enjoy meals with your friends and relatives. You live in an environment where there is a little bit of greenery is there. That is what you can do. Eat a lot of fibers. Your diet should contain a lot of fiber. At least 35 gram fiber should be there in your diet. Try to eat fermented foods, if possible. Let our children play in the ground, not in the computer room. Be little less conscious about the sanitation hygiene. Let us live in this environment. This is basically a microbiologist working in Stanford. She has published, she with her husband, Sonnenberg, Justin and Erika Sonnenberg, worked a lot on microbiome and relation with the diet. It's her environment around the house with her 2 children. She lives in the midst of American city. She lives in a house and the surrounding environment is like this. She's got a pets. The children play around the greeneries. She produced her own vegetables. This is one, again, they published a study looking at the husband's microbiome in 2010 and 2015. They found that with this plant-based diet, his microbiome diversity has gone up in the 5 years. Let our dining table be like this. I don't know, our kids will agree with that. Other than the food, there's a huge market for the pharmaceutical industry in this area. There are prebiotics. Prebiotics are basically food material which promotes the healthy microbiome. There are probiotics, which I have explained to you in the beginning of my lecture, where live organisms are given in capsules. There is a huge research going on, not only research in clinical practice, fecal microbiota transplantation. Media publish this as the remedy for each and every ailment in the human body. May not be true, partly true. Of course, it has shown a significant improvement in patients with antibiotic-induced diarrhea known as Clostridium difficile diarrhea. It has shown a remarkable improvement. That is one area which has shown a remarkable improvement with fecal microbiota transplantation. Of course, there are in every area the studies are going on, including autism spectrum disorders, Parkinsonism, Alzheimer's. There are human studies. Published human studies are there which shown an effect, improvement. But how much it is, time has to tell. And you have got the phage therapy, which is being said as the viral, said as the replacement for antibiotics. You have engineered bacteria, you have all this. It's a huge pharmaceutical industry coming up on these lines. But what I have told you is in the preliminary stages. There are some correlations with the disease. It's not causation. Correlation is not causation. Animals, most of these studies have happened in animals. I didn't quote any animal studies in this. Most of these studies have happened in animals. Animals are not humans. Humans are not a big mouse. Microbial presence is not the same as microbiome. It's entirely different. So you are finding an organism there doesn't mean that that's the cause of the problem. And the commercialization is every supermarket there is a probiotic. Every pharmacy is filled with probiotic agents. But you need to know whether you need to buy this, you need to eat this, which one to buy, and there are so many things involved in this. So we are taught that you are what you eat. It's true, but we can modify it. You are what your microbes eat. They decide what you are. There is a saying that eat to live or live to eat. There's a controversy, but I believe in eat to live. But you eat to live long, live healthy. When Descartes says, I think, therefore I am, we need to modify. I think, as my microbes and gut lets me think. And this field is very, very in its infancy. Just like Ronald Reagan said in 1984, it's morning in America. I'm saying it's morning in the belly. It's a very, very new field. New field, new horizon, new science. But you need to be cautious. There are several projects. US Human Microbiome Project, American Gut Project. You know, this is a public funded project, American Gut Project. Anybody can go and give your fecal matter, and you will get a report saying that these are the group of microorganisms that is residing in your gut, and you can modify your diet, your life practices according to that. We have reached to that stage. It costs only $100, not millions. There are several projects going on around the world. We too, India has got a microbiome project, but I don't know how much it has progressed. It was introduced 4-5 years back, I think 2016 or something. We have a project. I will stop here. Take up questions. Thank you.